first apply the elementary operation, then the determinant becomes very, very easy. Okay, so what are the row operations? What are the column operations? Let us see now. I'm going to give some example also. I'm going to take first capital A is any like square matrix. I'm taking A1, B1, C1, A2, B2, C2. And this is A3, B3, C3. Right. So the first operation or first transformation is interchanging row. That is nothing but Ri interchange to Rj. So R nothing but row. Ith row and jth row I'm interchanging. Ith row and jth row I'm interchanging. So here coming to this matrix, I want to interchange R1 interchange to R2. Let us see. This is the first property, interchanging any two rows or interchanging any two columns. Nothing but, so what is the first property of column? Like Ci interchange to Cj. So that is C1 I'm interchanging to C2 or C2 interchanging to C3. So you can take R1 interchange to R2 or R1 interchange to R3. Okay, so these are the possibilities. So R1 interchange to R3 or R2 interchange to R3. So any one of, okay. So based on the question we can apply. Okay, I want to interchange these two rows. So then A is equivalence. You should not write equivalence to C. I am interchanging just R1 and R2. R3 becomes remain same. So this is first row. This is R2. This is R3. So the given matrix having three rows. I want to interchange the two rows R1 and R2. Then R3 remains same, that is A3, B3, C3. So then R2 becomes R1, R1 becomes R2, that is A2, B2, C2. This is A1, B1, C1. That's it. So this is the first property, first operation. Okay, row operation. Then what about column? I want to interchange C2 and C3. I'm taking the same matrix here. Okay, then A1, B1, C1, A2, B2, C2, A3, B3, C3. So what are the columns here? This is C1, this is C2, this is C3. Three columns are there. I want to interchange C2 and C3. C2 and C3. I am okay. Very carefully you can observe here. C2 and C3 are on interchanging. What about C1? C1 remains the same. A1, A2, A3. Now C2 becomes C3, C3 becomes C2. So that is C1, sorry, C1, C2, C3. C1, C2, C3. Then what is column 2? B1, B2, B3. So that A is equivalent to like this. This is the first row operation, first column operation. Let us see what is the second operation. Coming to the second one, okay, right. Ri tends to some k into Ri. Otherwise, Ci tends to some k into Ci. Nothing but what I have done, some particular row. Ri is a particular row. So for that particular row, I am multiplying with k. I am multiplying with k. For example, I am taking the matrix is like 1, 2, 1 by 3, 4 by 3 is there. 1 by 3, 4 by 3 is there. I want to make them this value in integers. So what this is belongs to R2. This is first row and this second row. R2 tends to what should we multiply here? 3R2. 3R2. I want to multiply to R2 with 3. So then given matrix is A is equivalence to, then first row as it is 1, 2. But what about when we multiply with 3 in each and every element of row? 1, 4. Now, this is the second property or second operation, second transformation, right? So, multiply with K2 in particular. So, here I want to multiply R2 tends to some 10 R2. Whatever the given matrix, then A is equivalence to, okay, for what is the row I multiplied with 10? Second row, or simply you can take instead of 10k. So I am applying the transformation on R2, R1, R3 remains same. So what is R1? A1, B1, C1 and A3, B3, C3. Then what about R2? Multiply with K, KA2, KB2, KC2. Is it clear? This is the property 2 in the same way, column wise. So C1 tends to KC1. I want to multiply the first column to K. Whatever the resultant matrix A is equivalence to, I am applying on the given matrix only. So then K, A1K, uh, A2K, A3K. Remaining two columns are as it is B1, B2, B3, C1, C2, C3. So any particular row or particular column multiply with subscalar. So that is the second property. Then what is the third operation? So I have explained, like till now I explained four operations, two row operation, two column operations, totally four. And coming to third one. Third one is I want to do something. R1, Ri tends to Ri plus some k times of Rj. What did you observe here? What do you observe? So for particular row, I want to adding another row with multiply with k. Here we simply k is equal to 1, Ri plus Rj. K is equal to 2, Ri. For jth row, you multiply k, then R. Okay, I want to do one thing for the given matrix. Okay, R1, R3 tends to something you can R3 plus some KR1. What I have done for this third row, I want to add the first row which is multiplied by K, which is multiplied by K. Then the A is equivalence to what? So here, what is remains the same? Just you can observe the left side, R3. R3 value only will be changed. Here, what is the value will change? R2. R2 alone change. R2 alone change. Remaining R1, R3 change. So what about here? C1. C1 alone change. Remaining C2, C3 remain same. Like that. Here I am applying the row operation on R3. So R3 alone, remaining R1, R2 same, like A1, B1, C1, A2, B2, C2. So whenever you want to apply the row operation, okay, or transformation or column operation, then so what way, so wherever you are applying the operation, like I'm applying an R3, first you should write R1, R2. Then after you can apply this condition. Okay, because applying an R3, R1, R2 as it is remains same. What about R3 becomes R3 plus KR1? R3 is A3 plus KR1. Nothing but A3 plus, so here A3 plus KA1. Is it right? Now, same it is. So whenever you want to add any two rows, you should add the corresponding elements, right? Now, second one. So B3 plus KB1, B3 plus KB1 and C3 plus KC1, like. So B3, the corresponding element, KB1, C3 plus KC1. So we have to add the corresponding element. R1 plus R2, nothing but corresponding elements you can add. In the same way, the column operation. Okay, these are the main six operations we can use. See here, it may be plus or minus. Not only it is plus, it may be minus also. Ri minus, so R3 minus. KR1. So it will become minus, minus, minus. When you take plus, you will get plus. When you take minus, you will get minus. So these are the three row operation, three column operations. Okay. So based on this, we will discuss the exercise 3.4. Okay. By using row operations or column operations, then we can find inverse of a matrix. Inverse of a matrix. So it is very easy. So whenever you want to find the inverse of a matrix, either you can use completely row operations or completely column operations, but don't use both operation at a time. Okay, both operation at a time. Okay, let us see one question in exercise 3.4. You can choose any question like first, second, third. So from question number 1 to question number 14, question number 1 to question number 14, they given 2 by 2 matrices. Okay, 2 by 2 matrices. Then question number 15, 16, 17 alone 3 by 2. Okay, let us start. What is the first operation? Interchange any two rows or any two columns. And the second operation is multiply with a scalar to the particular row or particular column. And what is the third operation? We need to add any two rows. Any two rows. You can directly add or else you can multiply with some constant to that particular row and you can add. Okay, so these are the operations. Let's see. Maximum we can concentrate on row operations. Okay, to find the inverse of a matrix. Even if we ask particularly the column operation, by using column operation, find the inverse means in that case only we can apply the column transformation. Okay, let us see. Anyone can choose any question. We'll do that. 1 to 14. A student. What is the question we will do? Yes. Okay, I'll take myself right. Your wish. Let us do the first one itself because they given 1, minus 1, 2, 3. Negative value is given. 1, minus 1, 2, 3. Solution. Let us consider first given matrix as capital A. Let capital A is equal to 1, minus 1, 2, 3. So everyone should concentrate here. Okay, first I'll explain one 2 by 2. Then after we'll go for 3 by 3 matrix. Okay, 2 by 2, row wise, row operation and as well as column operation. Both the cases will do. Okay, look at here. Since we know that there is a property AB is equal to BA is equal to I. So what we can call it the both the matrices AB is equal to I, BA is equal to I. Then what about A and B? A and B. For example, x into 1 by x, that is nothing but x into x inverse is equal to 1. Then what about this x and x inverse? X and x inverse. Or x is inverse to x inverse is inverse of x. Nothing but 2 into 1 by 2 is equal to 1. So here 1 by 2 is multiplicative inverse of 2. 1 by 2 is multiplicative inverse of 2. 2 is the multiplicative inverse of 1 by 2 because finally answer we get unit identity. Multiplicative identity is 1. In the same way, coming to matrices, when the product of any two matrices becomes identity, then the given matrices are inverse to each other. Here B is inverse to A is inverse to B. How to write that? So when I multiply with A inverse here, A inverse of AB is equal to A inverse of I. So multiply A inverse into A is I into B is equal to A inverse. So finally B is equal to A inverse. Is it clear? So nothing but B is the inverse of A. The same if you multiply with B inverse, like from this step, AB into B inverse is equal to B inverse into I or I into B. So anyhow, here we are going to B into B inverse I. So A is equal to B inverse. Nothing but what do you observe when AB is equal to I? So B is the inverse of A or A is the inverse of B. Any one of the way you can write. Any one of the way you can write. So then if I substitute this B value here, B value in this condition, what about here? A into A inverse is equal to A inverse into A is equal to identity. A into A inverse into A is equal to identity. Then A is called, A inverse is the inverse of A. So I replaced A value, sorry, B value in this condition. Finally we got, right? Okay, fine. That is one of the properties. So given equation, we can change it to any one of this form. Any one of this form. Then how to change any one of this form? Either AB is equal to I or BA is equal to I. So how to change? It is simple. It is not at all difficult. So look at here. Now I want to take A is equal to I into A. I into A. So here I want to use row transformation. So why can't we take here A is equal to A into I? There are two cases will be there. A is equal to, we can write I into A or A into I. Am I right? We can write any one of the way, but I'm taking particularly I into A because of the reason whenever you want to apply the row transformation, you must write I into A, not A into I. When you write A into I, you must apply only column operation, not row operation. Is it clear? If you want to apply the row operations, you must take I into A only, then only you will get the inverse of a matrix. Otherwise, you won't get the inverse of a matrix. When you take A is equal to A into I, you must apply column operation, then only you will get inverse of a given matrix. Okay, let us see. I have taken like A is equal to I into A. Then what is identity? What is identity? Is it identity of order 2 by 2 or 3 by 3 or 4 by 4 or 1 by 1? Anyone? What is the identity we need to take?
2 by 2.
2 by 2 because it's depending on the given matrix. So given matrix of order 2 by 2. And also inverse of a matrix, inverse of any matrix is exist for only square matrix. The given matrix must be square, then only inverse exists. If the given matrix is not a square matrix, inverse does not exist. Okay, fine. Okay. So here I want to replace the left side A value. A value is what? 1 minus 1, 2, 3 is equal to right side is identity 1, 0, 0, 1 into A. Clear? But you should not replace the A value here, A matrix here. You should write simply A. I want to make them the RHS in the form of BA. BA is equal to I. BA is equal to I, nothing but, shall I write here I is equal to BA? Is it right? BA is equal to I, nothing but I is equal to BA. Nothing but what should we make here? The thing is, by applying the row operation, we can make them the LHS into identity matrix, identity form. We can use the row operation, we can change the LHS into identity form. Is that difficult? Not at all difficult. Look at here. First, what is identity? That we know that identity matrix of order 2 by 2 is right. LHS we can change it to identity form. Identity I is equal to 1, 0, 0, 1. So that LHS, this LHS we can change it to identity form by applying some row transformation. Okay, so what is the identity? When you observe the identity, the first point is that non-diagonal, this is diagonal element. Non-diagonal elements are 0. Even if you take 3 by 3 also, what do you observe here? 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So other than diagonal elements, non-diagonal elements are 0 and diagonal elements always equal to 1. So that is the identity. Okay, fine. So observe here, easier non-diagonal elements are 0? No. So non-diagonal are -1 and 2. Then I want to make them these non-diagonals first 0. After that only you can make them this diagonal elements are 1. That is easy. Okay, right? Let's see now. Okay, this is R1. This is R2. I want to use this R1. I want to make them this two values 0. So what is the row operation you want to apply to make this two element is 0? Shall I write like that? See, first I want to make them two value is 0. 2 is belongs to which row? 2 is belongs to which row? R2. R2 tends to fine. Write R2 minus. I want to apply the third property, third row property. I want to multiply this 2 here. 2 R1. Is it okay? Yes. What we need to do here, I want to make them these two values 0. For that, I need to apply some row operation. So this 2 is belongs to R2. R2 minus this one is a 2R1. Then this element becomes 0. Okay. Whatever the row operation you are applying on LHS matrix, the same row operation apply on identity also. On identity also, right? Very important. Okay. See, I clearly told you that I am applying the row transformation on R2. Then what about R1? R1 remains same. So I said very clearly, so whatever remains same, you should write first those rows. Right. R1 is remains same. So R1 is 1 minus 1. Right side also R1 is 1, 0 into A. Now R2 becomes change. Okay, what about the R2 minus 2R1? What about this element? R2, 2 minus
0.
0. Good. Then what about this? R2 minus R2, 3 minus 2 times of R1. What is corresponding element? -1. Nothing but it is 5. Is it okay? In the same way, R2 minus 2R1 apply on RHS also. R2, 0 minus 2 into R1 is 1. So 0 minus 2. Next, R2 is 1 minus 2 times of R1 corresponding element 0. 1 minus 0, 1. Once again, so I want to change the LHS into identity form. To change identity form, diagonal elements, half diagonals are 0. So this 2 must become 0. To make them 2 is 0, 2 is belongs to R2. I apply the property R2 tends to R2 minus 2R1. I'm using R1. I make them the 2 value becomes 0. Okay, fine. Now is it we got some LHS value. Is it LHS is a identity matrix?
No,
You
sir.
have to you have to apply like that row operation until you get the identity matrix. Okay, fine. I said very clearly, don't think about diagonal first. You can make them non-diagonal elements are 0 first. Okay, non-diagonal. Here -1 will be there. I want to make them this -1 is 0 now. Right now, I want to make them -1 is 0. Okay. What is the operation I need to apply here? First, -1 is belongs to which row? R1. Then this is R2. Now, I want to make them -1 is 0. -1 is belongs to R1 so that you should take R1 tends to. What I have to do here? What I have to do? To make -1 is 0, -1 is belongs to first row, 5 is belongs to second row. So to make them the value is 0, what to do? Shall I multiply here 5? 5 to -1. Shall I adding this? Is it equal to 0?
Yes, sir.
Yes, sir.
Yeah, what I have done, -1 is R1. For R1, how much I multiplied? 5. 5 R1. 5 is belongs to which row? Second row. R2. Yeah. I multiplied here 5 and adding to R2. So 5 R1 plus R2. Is it clear to everyone? I hope that it is very clear. So easy. So by doing 2, 3 problems, then you'll get complete idea about this. Okay. Clear. So now, then here I am applying the transformation on R1. So you can keep it as it is the R2. R2 remains same. R1 only will be changed. So what about R2 here? Left side and right side. R2 you can write it as it is. R2 value is 0, 5 minus to 1. 0, 5 minus to 1. Then now apply the operation. Now R1 5 R1 plus R2. Multiply first 5 R1. 5 into 1, 5 into 1, 5. 5 R1 plus R2, 0. 5 into 1. This is clearly 5. Next. Here also same property apply here. 5 R1, 5 into minus 1 plus 5. Nothing but obviously it is 0. So to make them this value only we return. So this is clearly equal to, what about the same operation you can apply here. R1. Yeah, do it, sprint yourself.
So
5
3
R1.
and 1
3,
and 1.
1. Yeah. Multiply here 5. 5 into 1, 5 plus of minus 2. 5 minus 2, 3. Multiply here 5. 5 into 0, 0 plus R to 1. So 3 and 1. Now can anyone tell that is it identity matrix? Is it
No, sir.
identity? No. It is a scalar.
Yes, sir.
Anyhow, how can you change it to identity? Again, this is belongs to R1. This is belongs to R2. Then R1 tends to R1 divided by first row dividing with what? Then you'll get 1. R1.
5.
Shall I do like this? First row I want to dividing with 1. 5. Sorry, 5. Then 5 by 5 becomes 1. You'll get identity. In the same R2 also, second row also dividing with what? Second row.
5.
5.
5. That's it. So first, here both will be changed. R1 will be changed. R2 also will be changed. Okay. So write then fine. So what about R1 by 5? R1 entire row 1 dividing with 5. 5 by 5 1, 0 by 5 0, 3 by 5 and 1 by 5. Okay. Next. I completed this first row operation. Then R2 tends to R2 by 5. R2 is 0 by 5, 0, 1. Now here minus 2 by 5, 1 by 5. Is it clear? Okay. See, finally, what do you observe? It is in the form of identity is equal to B into A. B into A, where I want to take this matrix as capital B. Capital B is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. Clear? So what do you observe? It is in the form of identity is equal to B into A. Whenever the product of any two matrices is equal to identity, product of any two matrices is equal to identity. What about B? Shall I write B as A inverse? B as A inverse. When I multiply with the A inverse on both sides here, this equation, post multiply. Okay. Then finally, this is a resultant matrix, nothing but inverse of a given matrix. So this is a given matrix. The inverse of given matrix is given by 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. Then how can you conclude that this is exactly correct answer? How can you say that? We can't say directly. So if you want to, you can verify that. You can find that B into A. You can multiply B matrix and A matrix. It should be equal to identity. Definitely will get identity. So if you are not getting identity, you did mistake like somewhere. Okay. So it is not necessary that to check in exam. In case if they give for 5 marks, you can check it like B into A, right? If you have time, it's better to you can check it once whether BA is equal to identity or not. Okay, I applied the column operation. First, what I have done, not only 2 by 2, even it is 3 by 3 also. The first thing is, other than diagonal, you can make them the non-diagonal elements are 0. Nothing but in case if they give 3 by 3, 3 by 3. So, look at here, look at 3 by 3. For example, you can take any matrix like 15th question. 15th question. Let us take again A. Just I'm explaining you can try. I think we have one more class. The question is 2, 2, 3 minus 3, 2. So minus 2, 3, 3, 2. Actually, it is very easy method to find inverse of a matrix by using operations. Only you have to remember 3 steps. Only 3 steps. What are the 3 steps? What is our target is 3 by 3. You can make them to identity form by applying root transformations. So remaining all elements are 0, right? So other than diagonal, non-diagonal elements are 0. Okay, fine. So what are the 3 operations you are going to apply first? The 3 operations are using this element. But it is belongs to R1. Using this 2, you can make them remaining 2 values are 0. Next, using this, because 2, 2, 2, these are the only elements diagonal. Using this middle value, you can make them these 2 values 0, minus 3. And using this 2, you can make them these 2 values are 0. That's it. How many steps we will get the answer? After that, if you get any value like this, you can R1 dividing with this particular value, R2 also dividing with this particular value. Here we are going to get R3 also, dividing with some particular value to get the diagonal elements 1, 1, 1. Okay, to get 1, 1, 1. So what are the 3 steps to get the identity form? Using this 2, you can make them corresponding elements of 0. Nothing but R2 minus R1, R2 minus R1. Here 3 is there. For this 3, you can multiply 2, you can multiply 3. Nothing but 2 R3 minus 2 R1, 3 R1. Like that, we'll do that question. Okay, in combined class, we will discuss the system of linear equation. Okay, in separate class, we will discuss this. And tomorrow, I can complete this 3.4. Nothing to worry about that. So in one class, we are discussing determinant in